Hey there, and welcome back to the Howard Kitchen for week 2, Tuesday, and day 2 of factoring. Today we're going to be taking a look at a different kind of factoring than GCF, completely different. This one is called difference of two perfect squares. I want you to recognize some words in there. Difference is a math word you've been working with for a long time. It means subtraction. Good. And perfect squares are those numbers that are square rootable, that have a perfect square root. All right, I know we've always debated on whether the word square rootable is really valid or not, but I'll use it anyway. So those numbers that can be square rooted perfectly. You can use your calculator to check those out if you need to. But if we have two terms attached by subtraction and both of them can be square rooted, everything in both terms can be square rooted, then you have difference of perfect squares. It's usually everyone's favorite kind of factoring once you get used to it. So perfect squares, remember 1 squared is 1, 2 squared is 4, 3 squared, 9, 4 squared or 4 times 4, 5 times 5, 6 times 6, and so on and so forth for 7 squared, 8 squared, 9 squared, 10 squared, so on and so forth. I think for the most part you're familiar with most of your perfect squares, or at least numbers that you know are square rootable even if you didn't know they were called perfect squares. So in order to factor difference of perfect squares, you need two terms. You need them to be attached by subtraction, and they have to be square rootable. Now, I hope you're writing down everything I write. If you're not, hit the pause button, get some paper, some pencil. Hopefully you've started that algebra notebook during this extended dismissal, and hopefully you will be just adding a new page to that. But if you haven't yet, do so now. Come back, hit the play button. We'll continue right where the fun left off. All right, so some examples. Let's do example 1. We'll call x squared minus 64. I always check, do I have two terms? 1, 2. Are they attached by subtraction? Ooh. Can I square root them? Well, sure, because x squared, the square root is x, because x times x is x squared, and square root of 64 is 8, because 8 times 8 is 64. In order to break down x squared minus 64, I'm going to have you dig deep in your memory to day 4 from last week where you were multiplying two terms by two terms. That last question on the homework was x minus 7 times x plus 7. When we multiplied those, we ended up with x squared minus 49. No middle term. That was the only time that happened. So, square root of x squared comes first. Square root of 64 comes second. Now, as far as what signs go in the middle, you have a decision to make. I need them to multiply to give me negative 64. What times what will give me a negative? All right, a positive times a negative. So there's your first example. Number 2. We'll still keep it simple. We'll throw some weird ones at you pretty soon. Square root of x squared comes first. Square root of 36 comes second. Signs in the middle, they just have to be opposites, so they multiply to give me a negative. All right, let's take a look at a little bit of a weird case. What if I have more than one value in that first term? Then you have to be able to square root both. Are there two terms? Are they attached by subtraction? Can I square root that whole thing? Yeah, you can, because the square root of 4 is 2 and the square root of x squared is x. So the square root of 4x squared is 2x. That comes first since 4x squared came first. Square root of 25 is 5. And then you just need one minus and one positive. It doesn't matter which one goes where. You can put the positive first and the negative second. As long as you have one of each, it does not make a difference. Another slightly different one. What if it kind of looks like the order is changed? Well, that's okay, because the square root of 144, since 144 is first, the square root of 144 will come first. What is the square root of 144? Oh, hopefully you know it's 12. If you didn't, you put square root of square root of 144 in your calculator and get 12. Square root of x squared, x. And what kind of signs do I need so that it multiplies to give me negative x squared? One of each. And it does not make a difference which one goes where. So there are two potential answers there. You could have the positive or the negative first. It makes no difference. All right, let's do just another 9x squared minus 225y squared. See if you can take a guess on what those two factors will be. And then just to scare you a little bit, because, you know, we're not there in person, so I can't see your reaction to fractions, so I'm just going to imagine it. What if I have a fraction and a higher exponent? Actually, let's not do a 4. Let's do, oh, blue circle of doom, I should have known better. Let's do a 6. So square root of 9x squared first. Square root of 225y squared second. That's 15, by the way. And opposite signs, I don't care which one you put first. I'm going to put plus first so that you know I'm in a positive mood about getting you through this math course. Fractions, top and bottom. Treat them as separate numbers, but put them back together when you put your answers in. So square root of 1 over square root of 9. Square root of 1 is 1, square root of 9 is 3, so square root of 1/9 is 1/3. It comes first since 1/9 came first. And square root of m to the 6th, well, if I'm doing square root of a variable with an exponent, all you do is take half of the exponent. 1 minus, 1 plus. Oh, there goes the positive mood. Wasn't even thinking about it. All right. So tonight's homework, you've got week 2, day 2. It's Tuesday's assignment. Go ahead, do it. Attach it to the assignment so I can take a look at it and grade it and get it back to you. All right. I hope you're doing all right. Drop me an email if you need anything or if you're having issues with anything working. All right. Take care.